Hi guys, my name is Leonardo Falcon. In this video, I will be showing you the basics of sound localization and how it pertains to binaural recording. Even though we have only 2 ears, we're able to localize sound three-dimensionally. The coordinates used to describe this localization are azimuth, pertaining to the horizontal angle, elevation, pertaining to the vertical angle, and distance. Azimuth describes the sound direction on the horizontal plane. Depending on frequency, our brain uses one of two techniques or both. If the frequency of the sound is below 800 Hz and above 80 Hz, interaural time differences dominate. This is because at low frequencies, the human head is about half the size of a wavelength, allowing for a perceivable arrival time difference or phase shift in the signal as perceived by the two ears. Between 800 Hz and 1600 Hz, ITD and ILD, or interaural level differences, are used to localize sound. ILD dominates at frequencies higher than 1600 Hz. This is because sound does not wrap around the head as easily as it does at lower frequencies. Essentially then, at higher frequencies, the head blocks sound to the ear furthest from the source, creating what is called a sound shadow. A perceivable difference in amplitude is then used by the brain to find the location of the sound. When detecting elevation or the medium plane sound localization, the brain uses monaural cues which are associated with the resonances in the shape of the pinna of each ear. Our ears are asymmetrical, causing for different signals to be processed at each ear, and hence distinguishing elevation. The head, shoulders, and torso add information to the signal perceived by the ear. This filter, if you will, adds three-dimensionality to our ability to determine sound direction. Binaural audio recording is a technique for creating the illusion that sound is coming from somewhere other than the center of the head when the user is using earbuds. The technique to accomplish this are dummy head, operational listener, and head-related transfer function. Dummy head is an artificial model of a human head constructed using materials that replicate the cranial inner acoustics of the average human. Two microphones are placed where the ears would be, and they correspond to the signals that will later be played back. Another technique is known as operational listener, where the mixer uses his own head to test inner acoustics and create directionality effects. He or she accomplishes this by adjusting filter dials and assessing the results. The head-related transfer function is a signal processing technique that derives from the Fourier transform of the head-related impulse response. When convoluted with a sound source, it creates the same filtering effects that do the external human anatomy. When the resulting signal is fed directly into our ears, binaural directionality illusions can be created. All these techniques do not work for everyone as they are established using the cranial inner acoustics of the average human being.